All right, welcome to today's Book of the Day show. Very special guest, Dr. or Professor Joseph LeDoux. He wrote this book, Anxious, and he's the Henry and Lucy Moses Professor of Science at NYU. So he's a member of the Center of Neuroscience and Department of Psychology. He directs the Emotional Brain Institute at NYU and at the Nathan Klein Institute, and a member of the National Academy of Science. This guy knows his stuff. And I always say, I think it's Alexander the Great that said there's only two types of people. The first type of person conquers fear, and the second doesn't conquer it and suffers and dies. So all of us in a world where there's so much to think about suffer from some level of anxiety. And so we're going to talk about what you need to know here straight from the professor who's studied the brain. I have my colleague, Dr. Gurman. He doesn't like when I call it.
Fresco.
Dr. Herman Garcia Fresco. He is a molecular neuroscientist. So, welcome.
So fear is what we call fear is a useful thing because it's things that are dangerous are encountered every day in life, not just because of evolutionary reasons. I mean, people don't usually run into bloodthirsty beasts on the streets of Manhattan, but there are lots of other things that are dangerous to us. Now, there's been a long-standing confusion in psychology, neuroscience, biology, and part of this goes back to Darwin, where we've confused fear with more basic mechanisms that help us stay alive. So Darwin called emotions like fear states of mind that we've inherited from other animals, and I think this is absolutely wrong. We haven't inherited states of mind. What we've inherited are circuits that control particular behavioral responses. For many years, my research has been talked about as having been all about the discovery of how fear lives in the amygdala in the brain, and that's absolutely not correct. Fear is not something that hops out of your brain when you turn on the amygdala. The job of the amygdala in a situation of danger is to detect the danger and to provide you with behavioral responses that allow you to cope with that and physiological support for those responses. So that's why you may freeze, you may faint or whatever, and your heart is going to, if you're freezing, your heart may be beating faster, your blood is moving around in your body, you're sweating, and so forth, because these are all needed as part of the physiological support of a very intense, energy-demanding response like freezing. Now, this is something that will occur in a rat and a human, when a human finds him or herself freezing in danger, they're also experiencing fear. So we tend to assume, we correlate in our own minds the feeling of fear that we experience with these behavioral responses. But when we go into the brain, what we see is that the behavioral responses and the feelings of fear are not coming out of the same brain systems. Those are completely separate things. So if I take a person, bring them into the laboratory, show them a threat, their amygdala is going to be activated if we measure this in functional imaging or so forth, and they're going to feel fear. But if I show that person the threat subliminally, so they don't even know that the threat is there, the stimulus gets into their brain, activates the amygdala, and responses come out. For example, heart begins to beat faster, but the person doesn't feel any fear. So fear is not necessary for the control of these responses. Fear is a separate kind of process in the brain. And basically the idea then is that all animals have to be able to detect and respond to danger, but only animals that can be consciously aware of their own brain's activities and to be aware that they exist as an entity can experience a feeling of fear.
So it's kind of like
confuse these two things. Sorry?
It's almost like we have an this automated response that we share with mice, and we share maybe even house flies. But humans being, and I once met one of the top philosophers. I forget his name now. He's written all the textbooks, but he asked me a question because I lived on a farm. He said, "Tai, do you think animals are conscious?" And I thought yes, but he's 80 years old, and he said I think that humans are the main species that are conscious in this sense, and so only whether it be humans or these more evolved brains, we're the only ones that not only have this automatic response, but we also can think it through in deeper context, like what the fear means to us, how this could affect us in like
it's more than that what the fear means to us, the ability to experience the fear.
Huh.
So, I don't really want to draw a line between humans and other animals, but what I want to say is that we simply don't know what another animal experiences. And on the basis of the evidence I just gave you about the human not needing the feeling of fear to respond to a threat, means we need to be very careful about whether when we use observable responses in animals to assume that they are feeling what we feel. Whatever, maybe animals feel something. They have experiences of their own kind, but whatever it is, it's not going to be like the kind of experience that the human brain can have. With we have more than 30-something words, 37 or 38 words in the English language alone for variants of fear and anxiety. We have trepidation, consternation, fear, avoidance, terror, horror, panic, and on down the line. And these are gradations of experience that our language classifies. So as an experience is unfolding, we begin to label it. We learn these labels as we grow up as children and apply them to our experiences. So the human brain's experience is going to be very different from any other animal. And so I don't think it's fair to start with the highest levels of human evolution, for example, our ability to conceptualize our experiences, like fear or love or joy or anger and so forth, and to use those very complex concepts to then go looking for emotions in the brains of animals. In other words, we shouldn't be looking for human emotions in animals. We should be asking, what is it in the animal brain that is also relevant to the human brain? And that is something we can study very extensively.
Let me interrupt you. I completely agree with you with where our emotions are completely different than animals. But I have just a little example. When I was young, I had this beautiful Dalmatian, and I accidentally shot him with a little BB gun. It was just an accident. Every time that I would pull out the BB gun after that incident, it would run away. So do you think that's purely primitive, or there's some sort of conscious processing there, like some emotional feeling, an emotional feeling of the dog?
Nope. That's absolutely not necessary.
Okay.
What you're talking about are responses that are controlled, in this case, by the amygdala, the ability to detect and respond to the danger, to run away from the danger. You don't need to feel fear. Fear is not part of that sequence.
Okay.
Fear is something else.
So basically,
that's separate adaptation in the brain.
So basically, my dog saw the gun, and it was
an association kind of survival.
It directly activated the amygdala.
Yeah, Pavlovian.
Okay.
All right.
Again, I'm not saying that dogs don't have any kind of feelings, but it's not.
But we don't know.
Not what we mean when we use those words like fear. They have some kind of protective response. Let me give you a really extreme example. Bacterial cells have to do 5 things to stay alive in their environment. They have to detect danger and respond to it. So if there's harmful chemical in their environment, they have to move away from it.
Yeah.
They have to incorporate nutrients inside the cell wall in order to make the energy supplies they need. They have to balance their fluids between the internal and external environment. They have to thermoregulate because all the enzymatic reactions that take place in the bacterial cell are temperature sensitive, as is always the case. And they have to reproduce for their species to survive. Those 5 things are the things that people study if they're interested in studying emotions in animals. But if we take it all the way back to the bacterial cell, we see that those are not things relevant to emotion.
Yeah.
Those are processes that keep the organism alive. And it doesn't matter whether you're talking about a human or a bacterial cell, those 5 things are part of daily life and daily survival. So when you take those 5 things and you put them into a brain that can be conscious of its own activities, then you begin to have the conscious experience of hunger, the conscious experience of sexual desire, the conscious experience of fear, the conscious experience of thirst. Otherwise, you have behavioral systems that motivate the organism to satisfy thirst, to satisfy hunger, to reproduce, and to protect yourself from danger, without necessarily, and again, we don't know what another animal experiences, but if we really put it into concrete terms, we have to ask two questions when we're asking about animal consciousness. Can the phenomenon be accounted for in a way that's consistent with consciousness? And can we rule out that that behavior is not due to a non-conscious process? And across the board, I would put a lot of money on this, that it's going to be hard to prove that you can't use a non-conscious explanation for most of the things that are soon to be conscious in animals.
All right, let me ask you, one of the things I liked in the book, you were talking about towards the end of the book. It's a great book, by the way. If you're listening in, make sure to buy Anxious. So one of the things that I find interesting in practical application is this theory, and you touch on this in the book, of exposure therapy. So there's this one Far Side, the cartoon that I like, and there's show a picture of a guy in an elevator being dropped, and he's just falling from the sky, and he's surrounded by snakes. I mean, snakes are all on top of him in the elevator, and the cartoon says at the bottom, Bob was simultaneously trying to cure his fear of heights, tight spaces, and snakes. And so that's this idea of exposure therapy. Like, if we're afraid of public speaking, you start out speaking to one person, then you speak to two people, and the next thing you know, you can go on stage. Is that a viable, because you talk about in the book some of I think you have a chapter or a few pages I read on where that doesn't always work. Like, if you use exposure therapy, but then you're under stress, you might revert back to your phobia again. But does it work in general to expose ourselves to fears?
Yeah, so it's very effective to work with a therapist. The cognitive therapy is the most popularly used form of therapy for problems with fear and anxiety these days, and in particular a thing called cognitive behavioral therapy, which has this procedure called exposure as part of it. So it's very effective in temporarily reducing these kinds of problems, but the problem is that it's not permanent, and a variety of things will cause the effect to dissipate. So a lot of effort is going into the science to try and figure out how to make exposure therapy more durable. And there are lots of things that have been discovered. For example, there's a drug called, let's back up a step. So exposure therapy is based on the simple procedure of Pavlovian extinction. So Pavlov's dog, you ring the bell, give the dog some meat powder, and then the dog salivates when he hears the bell because of the association between the bell and the meat. Now, if you give the bell over and over and over again, the dog will stop salivating because it's no longer reinforced by the meat. So that's called extinction. In the case of a threat, you have something that's threatening to you, say some street corner where let's say you've been in a car accident, so you don't want to get in cars. So gradually look at pictures of cars and maybe touch cars, eventually sit in the car, and then eventually ride in a car and so forth, to gradually reduce the impact of the ability of that car to be a threat trigger and cause you to be aroused and upset and so forth. So it works pretty well. But then let's say you've been treated, and now you have to drive past the intersection where you had your accident, and maybe it all comes flooding back at that point because the cues there revive the old memory. So what's going on in extinction or exposure is that a new memory is being created that the stimulus is safe. And the old memory is still there, though, because it can always be brought back. And the question then is, can you make that new memory of safety stronger so that the old memory of threat is less likely to pop back up? And one way that's been proposed to do this is by using drugs. So this is not drug therapy. This is like a one-time shot of the drug during exposure therapy to make that learning more durable. And then after that, because the learning is more durable, then the exposure should persist longer. And there's some success with that approach. This drug is called D-cycloserine, and it's been used to help people with phobias or to help treat certain symptoms in post-traumatic stress disorder and combat victims and so forth. But it does involve this use of this drug.
I read that they call those fear annihilation memories. So you create those I read an article, I don't know if this is accurate, that the MPFC part of your brain, your amygdala stores this memory of, you got bit by a dog, and you never can really get rid of those memories. You can't completely remove them, but what you do is you create these new MPFC fear annihilation memories, and your brain basically, if they get strong enough, and this is obviously not the exact process, but your brain looks to the amygdala and then also looks and sees if there's a fear annihilation type memory, and so it can, in a way.
That's not the right way to describe it. The brain doesn't look. What happens is that the circuit between.
This is why I'm glad I have you on. You can correct all my colloquial brain expressions.
So the medial prefrontal cortex and amygdala are connected in a circuit, and when you undergo extinction, that circuit develops the ability to the medial prefrontal cortex to inhibit the output of the amygdala. So the amygdala can no longer express the response to the threat, even though the threat is there. You've shut it down, so to speak. So the amygdala can be thought of as the accelerator, and the prefrontal cortex, medial prefrontal cortex, is the brake. But what happens is the brake weakens or is removed by these other kinds of experiences. Now, when you take this drug during the extinction training, what you're doing is strengthening the ability of the brake to clamp down on the amygdala.
Yeah.
Now, we discovered a way to do that completely without drugs through studies of rats. So, for example, it was an accidental discovery, and what normally you would do is you would give the stimulus, say, 30 times over and over again, say once every minute or a minute and a half, until the response is weak. But the student doing those experiments did the first trial, and then for some reason in that group of animals, she could only do one trial. Maybe I think the apparatus broke or something, and it took her 10 minutes to fix it. So she had introduced a 10-minute break between the first trial and the second trial, and then continued with the one trial every minute or so after that throughout the 30 trials. And the funny thing was that because she had done that in that small group, she did it in the rest of the animals she was studying in that experiment. So she got a big group of animals that had one trial, a break of 10 minutes, and then all the other trials together, bunched together. And what she found was that when she did that, the responses never came back after that kind of extinction.
Huh.
And
was it the break?
So,
Was the key, having the break?
Well, what happened was it's very complicated, but let me tell you the implication first. So we did this together with my colleague Liz Phelps and Danielle Schiller at NYU. We did this in humans. These are not people with anxiety disorders, but just college students doing an experiment. And so we tested them in the same way, compared to a group that just had the stimulus over and over again in the usual way. And again, in the people who had the break between the first trial and the second trial, the responses never came back. Even after a year, we brought them back into the laboratory, they didn't come back. So this group of researchers at the National Institute of Health and collaborating with researchers in China took drug-addicted rats, exposed them to relapse cues. In other words, what you would do in a rat is the rat might be addicted to cocaine, for example, and the relapse cue would be a tone that every time the rat hears the tone, it gets the cocaine. So then what you want to do is extinguish that tone. So it would be similar to an addict who's exposed to paraphernalia cues. When they see the paraphernalia cue, they would want to relapse, but if they've been extinguished, they're less likely to relapse.
Huh.
Now, if you do that extinction in the usual way, one trial right after another, it works for a while, but then the rats eventually will relapse. And the same thing with addicts. So what they did was they tried our new method, where simply putting that 10-minute space between the first and second trial, and the rats were less likely to relapse. And they also did it in drug addicts, who also then were much less likely to relapse in the presence of the cues.
Well, for a drug addict, for a human, so you're obviously not using an exact apparatus. What would change? What break would there be in order to increase the likelihood that they won't relapse in a human?
The key thing is the separation of the first trial from the second trial. Now, what that does is it sets up a molecular process in which a neurotransmitter called glutamate and its receptors are engaged in a particular way, and starts in motion a series of molecular cascades involving various enzymes and kinases that are involved in protein synthesis. So when you set that up and allow 10 minutes for it to be established, you then are in a state of the brain where the brain is going to rewrite that experience, that stimulus, as safe rather than dangerous, in a way that is less likely to be unwritten or unreleased again. So basically, it's a way of creating a very strong, very powerful safety memory for a stimulus that was once threatening.
So if somebody's overweight, let's say somebody finds themselves, or let's take drugs or cigarettes. So somebody listening in, they smoke a lot of cigarettes and they want to quit.
Right.
So what would be the first thing that they do according to this study? I'm not saying you're a proponent of this, but in this hypothetical situation, how would a human set that up in their own lives?
Okay, I mean, I have no idea if it would work, but because we haven't done that. But the idea would be you would do exposure therapy, which is common for cigarette smoking. Show pictures of the person's favorite cigarette pack, I mean, I have to think through this because I'm not exactly.
So, are you saying instead of them actually smoking, you would just expose them to things that keep them kind of satisfied, like
cues of stuff that.
Let me think about that. Okay, so I guess what you could do is present them with pictures of cigarettes, or exposure to actual cigarettes, or cigarette boxes, or cigarette ads, or whatever, over and over again, to weaken the craving for the cigarette, just as they did in the addicts. Right? So over time, then it would weaken, and then but it would be temporary, but it wouldn't be that effective. So the idea would be that if you could do this thing in this particular way of doing the first trial and then the second trial with a break, it would create the memory of safety. Or it's hypothetical at this point because we haven't done it in addicts. I haven't done the drug studies in rats or people either, so I don't exactly know how all that works. But I do know in the case of a threat stimulus that is no longer followed by an aversive consequence, then that memory gets rewritten as not as a predictor of threat, but as a predictor of safety, because nothing bad happens when you remove, when you present the stimulus without the aversive consequence, nothing bad is happening. So it becomes associated with safety rather than danger. And that is the memory that gets stored through this process.
That's fascinating. I mean, it goes to show, one of the things I liked in the book is, the book's good because whether you are very knowledgeable, a scientist already, you'll find something fascinating in the book. But in the last chapter, as you get through the book, if you know nothing about the brain, and you talk on some real practical things that work. For example, you talk about simple meditation and breathing. You have it on page 313, breathing away anxiety. Your brain takes care of all the breathing, and you talk about the wisdom just take a deep breath, and how there's some grain of truth in this because it overshadows when we're stressed, right? Our sympathetic nervous system dominates. And so by breathing, can you talk a little bit about just simple breathing, what that does?
Yeah. So first I need to just put in a proviso here because apparently some Portuguese newspaper wrote an article about my book saying, if you have post-traumatic stress disorder or other debilitating diseases, all you need to do is breathe. And I got all these emails from people saying, are you out of your mind? Do you know what I'm experiencing? So that's not what it's about. This is for people who are not, with severe anxiety disorders, but, for the everyday stress of life. If you are able to learn how to breathe in a proper way that you could be taught through a yoga class or a meditation class, you would learn how to do deep abdominal breathing that controls the flow of air through your system in a way that entrains, causes the brain to engage the parasympathetic nervous system, which counteracts the sympathetic or fight-flight system in your body. And that shuts down the flow of hormones from your body into your brain, and kind of shuts down, reduces the arousal or hyperarousal that you might experience in a situation of anxiety and stress and worry. And when you do that, it takes the edge off of your conscious experiences, so that you can now focus more in a more kind of peaceful way on what it is you want to think about and what it is you need to actually do in this situation. So rather than being just paralyzed psychologically by this drive of hormones from the body into your brain that's causing your mind to be clamped down, when you remove all of that arousal by breathing in that way, it sort of opens up your ability to focus, concentrate, and attend to what you need to attend to.
I have another question, Doctor. If fear and anxiety partially is it's a conscious process, for what I gather from your book, and we're talking in certain area of the book, you're talking about how some people are more anxious than others, some people are more fearful than others. Would you say part of that is because of early experiences in life? Because obviously, if it's not inherited, if it's all based on experience, somebody that's a lot more anxious by the time they're 15 or 20, is that because of early exposure, or it's just an accumulation of, or even young kids? I have 2 kids, and I can tell one is more anxious than another one. Is that just experiences, or there is a genetic component?
It's not all experience. Your brain is wired by your genetic makeup.
Okay.
And that endowment will, if you think of every kind of brain circuit as having its own little bell curve of normality, right? And so each circuit is going to be selected or finely tuned by your genetic programming as you develop in life. And I shouldn't say finally, it's going to be set up by your genetic endowment. And then the experiences you have as you go through life, including very early experiences in the womb and so forth, the chemical environment that you're growing up in, those experiences are going to fine-tune the way those circuits function. So you're going to be born with an amygdala that has certain circuits for detecting and responding to threats.
So it's this combination of nature and nurture, even when it comes to us being...
It's always a combination. But if you think of these circuits as being set up, then the circuit is set up. It's going to vary from individual to individual. It will be more sensitive or more reactive in some people than others, simply because of the genetic variation, family history, and so forth. But then the experiences are going to either pull it in a more reactive direction or a less reactive direction, depending on what kinds of experiences you have. So it's always some kind of combination.
It's always so combination. Well, awesome. Well, this was a great talk. So tell us about, for 1 second as we close, tell us about your band, the Amygdalas.
Yeah. Amygdaloids.
Oh, Amygdaloids. Okay.
Amygdaloids.
We've been around for a while, since 2006. We have our own genre of music that we created. It's music about mind and brain and mental disorders. And in the book,
That's awesome.
in the preface of the book, there's a QR code where you can use your smartphone and download the latest CD, also called Anxious, which has songs that are inspired by various themes in the book.
Do you play
The
music?
title track is
Are you in the
I'm a
band?
guitarist, and I write the songs, and
You
I
write the
sing,
songs.
and I
That's
play
cool.
guitar.
So if people,
So Anxious.
so that's a great way to follow up. We're talking about anxious. Go out and buy this book. Anxiety, fear is something, the best way to, in my experience, to make progress in life is to start with a strong knowledge base. A lot of people want to change things in their lives, and they don't start with just raw, good knowledge, good science. And so you make assumptions that lead you down the wrong path. So this is a great book. I recommend it. If people want to follow you, is there a website? Is there a Twitter? What's the best way to reach you?
Twitter.
So the best way to reach me is through my Facebook website, Joseph LeDoux Facebook, or my lab's homepage, which is cns.nyu.edu. Sorry, cns.nyu.edu/LeDoux, or just type in LeDoux at NYU and you'll find me. Twitter, I'm called @theamygdaloid.
Yeah.
And so that's another way to follow. And the band is at www.amygdaloids.com. That's AMYGDALOIDS.
And I'm going to check out your other books, the Synaptic Self and the Emotional Brain. So everyone, thank you, Professor LeDoux. Thank you for everyone for listening in. And we will talk to you soon.
Okay, thanks, Ty.
Thank you, Joe.
Bye.
Have a good day.